All right, ladies and gents, now that you had the chance to kind of like see the examples, the Cornell notes, before you start the practice, let's run through a consolidation. So these are all the relationships you're responsible for. Let's get this into a form where you can like maybe reference it really quick. And so this is not designed to have specific examples, but to help you connect visually. So let's take a look. So the first three relationships actually are ones that we've seen before, but you're going to see them again in this section. So it's worth kind of bringing it up. So let's talk about a bisector. So you should call a bisector just means something's cut into two congruent pieces. So when you talk about a typical picture here, and again, pause the video if I'm going too fast. There's really two pictures you should be aware of. Like one is going to look like this. So you have a segment, and then you have a piece in the middle. And so like maybe it's marked. Or the other one is like an angle. So you have like this angle that's formed, and then you have like this line that cuts to the middle, which is a bisector, and it cuts the angle in half. And so remember, the bisector means you've been bisected by a bisector. And so these are the pieces that are actually the bisector, but the whole thing's been bisected. Now, the important thing here is that when you look at the typical equation, is if you know that the thing is congruent, that means your equation should be something is equal to something else. Congruency drives the equation where two things are balanced. Midpoint is something that I don't think we talked too much this year, but certainly in other years you would have had it. It's actually a really close cousin to bisector. A midpoint is just means that the point has cut a segment in half. And so the picture we'll draw is actually the same one as we have up here. Now the interesting part here is that bisector can apply to angles and side lengths, but a midpoint can only be a segment because it's limited just to a point. Like that's the midpoint. Okay? And there's ways you can calculate that, but the important thing is a midpoint is just like a bisector. And so the equation we'll have, since it is congruent, will also be like an equality sign. Okay, so now congruency, one we dealt with in the last unit, it just means parts of shapes or shapes themselves have the same measurements as angles and side lengths. And so a typical picture might be something like this. Like so you have, let's say a line or like a triangle here, and you know that like these sides are congruent, or you might have something where you have even like a whole shape. Let's say you have two triangles, and it's all marked the same exact way with these markings, and so you know the pieces are going to be likewise congruent. Congruent is a key feature here. If we're talking congruency, then we're talking something equal to something else. Okay, here are the ones that we added kind of today. So we have segment addition postulate. This is the one where you're taking the sum of the parts of a segment and they're going to equal the total length. And so when you talk about a typical picture here, let's kind of zoom in, that means you have like this whole segment, then you have like a point that divides it. And so this might be something where like this is like 3x, and this is like 15, and the whole thing is equal to like 45 or something. And so the equation we'll have here is a totaling equation. Sum means you're going to be adding, and so you have something plus something equals something. Because it's a general segment, we don't know a total length, or it's not always going to be the same total length. And so the last part, the total, also has to kind of be open-ended. Angle addition postulate. And so this is just like the segment addition postulate, except you're adding parts of angles. And so if you have like this angle and it's cut into multiple parts, so let's say this is like 4x plus 1 or something. This is like 25 degrees. But then you have to know that the entire angle is also something. So like this entire angle from here to here, let's say it's 90 degrees or 70 degrees total. Okay? And since we're adding things together, again, we have a sum just like we had before. We have the sum total. Okay? The equation that we're going to have is also going to be just like the previous one. One angle plus the other angle equals the entire angle. Okay? Vertical angle theorem. Those are the scissor angles. So we have angles at an intersection. They're across from each other, non-adjacent. Adjacent means they're like in a row. We're looking for angles that are like here and here. Okay? The important feature is that we know is congruency. And so congruency means two things are equal, so one angle equals the other angle. In this case, it's probably going to, it's going to be like the angle on the left is equal to the angle on the right. Now those could also be like up and down angles, like top and bottom. It's just dependent on what the picture shows, but the important part is those angles should be the same value, hence equal to one another. Linear pair postulate, so two or more angles that form a line, we know they're supplementary. And so we have a line, and we just have multiple angles. In this case, it's usually just two that form a line together. So if I put this one together with the one right next to it, they form this line along the bottom, the red line, which I tried to highlight, but I did not do a good job. They form this line together. So an important thing to note here is that the relationship is supplementary. So that means it's not actually a equation that comes from linear pairs. It actually comes from supplementary. And so remember, supplementary means you add to 180 degrees. Now the picture is going to be the same. So I'm just going to copy and paste this picture down here. Because they kind of go together. If something is linear paired, that means they're supplementary, but supplementary is the actual thing that gives us the equation. If it sums to 180 degrees, that means we'll have one angle plus a second angle equaling 180 degrees always. Okay. Last one, but not least, we have complementary angles, angles that sum to 90 degrees or form a right angle if you want to call it that way. And so we have this angle that we know is 90 degrees, and you just have more than one angle, or more than one part that you know about it. And so because we know the sum total is always equal to 90 degrees, sum meaning that we add together, but we know the total is locked at 90 degrees. Oops. Degree measurement, okay. So that's a quick cheat sheet, guys. This just like the last section, you have the notes that give you more detail, maybe some examples. This is just meant to give you a reference. The thing for you I think is going to be really important is connecting the idea to the equation, because we're going to be dealing with a lot of algebra in this section. Okay, so that's the quick cheat sheet notes. Of course, obviously I went too fast, go back, pause, read, watch it. But in the end, you're going to be responsible for all of these relationships. And so the practice is now going to come in 3 different levels. You have level 1, level 2, and then your homework, where you're going to have to be able to identify these postulates and theorems and these relationships. And then the second part, put them to work solving some algebra stuff. Okay? So thank you. Go ahead and grab the practice from me now and get started. So have a great day.